Hi, everybody, and welcome to another episode of the IaC Podcast. I'm Ohad Maizish, and today we have an amazing guest, the creator of SaltStack, Tom Hash. Hi, Tom.
Hey, great to be here. Thanks for having me on.
My pleasure. Tell us a bit about your background, please.
Yeah, sure. So I've spent most of the last few years working on Salt, of course. I started working on Salt in 2011, and then we incorporated a company in 2012. Before that, um, I was the principal architect for a music startup called Beyond Oblivion. They fulfilled their name. They went beyond Oblivion and failed. Before that, I was doing infrastructure management for the U.S. intelligence community. And before that, I was a trainer for Red Hat. So yeah, my whole career has been in the data center in infrastructure, and it's been interesting too. The last few years, I just got so we sold SaltStack to VMware in 2020, and they locked me up for 4 years, and I've only been free for a few months now. Uh,
Mhm.
Post Broadcom buying VMware, that was a ride, but it was really interesting to get so many different perspectives on how infrastructure's rolled out over the years and to see it evolve.
Can you definitely, and we will definitely going to talk more about that. But can you start by sharing with everybody here the reason, the rationale why you created SaltStack?
Well, I mean that's kind of tricky because my kind of ridiculous long-term dream is I'm one of these distributed operating system guys that I always wanted to make a system that was a legitimate distributed operating system. And I started working on Salt as a kernel for a distributed operating system. But I didn't know what I was doing, and it was like the fourth or fifth iteration that I had on doing kind of the remote command backplane. And I was sitting there at Beyond Oblivion one day, and one of my buddies, Joseph Hall, says to me, "Hey Tom, you hate Puppet because we were using Puppet." He's like, "Why don't you just add config management to this Salt project you're doing?" And I argued with him for a few weeks until I said, "Yeah, okay, I'll add config management." And we were able to take our Puppet code base down from we were able to reduce it overall by about 80%, moving over into even a super early version of Salt, and it was significantly faster. And so I guess one, I made it because I wanted to do this distributed operating system thing. Two, I kind of wanted more credentials as a software engineer. I was considering migrating out of systems management and into heavier development roles, and wanted to just have something for my resume. And I was really surprised when we had initial people like LinkedIn and Harvard and Wikimedia start using it so incredibly early. And that was yeah, it was a real trip to be able to kind of step back and say, "Oh my gosh, people are using this thing." This thing I just kind of chucked out on the internet.
Got it. So for those who are not aware, you mentioned the potential limitations that you might have with Puppet back then. So can you just explain what is SaltStack for those who are not aware?
Yeah, so SaltStack is a complete configuration management platform and infrastructure management platform. So generally speaking, we get lumped into the same camp as Ansible, Puppet, and Chef. But where the argument comes back is that those tools are very focused on just kind of the config management vertical. Now, Salt has a world class and I would say the world's best config management system. I am biased, I'll own that. But Salt is also all about its remote execution backplane and its event driven infrastructure system. So the idea is that instead of being a day zero tool where it's just for setting up, it's a continual infrastructure management system where not only can it do everything that Puppet and Chef and Ansible can do, but Salt also has the ability to ask arbitrary questions of your infrastructure instantly, be able to make large scale changes to your infrastructure instantly, And still, even though I originally wrote this back in 2011, it is still by at least an order of magnitude the fastest way to communicate with large scale infrastructure. So it's a very different platform and it's built for scale. That's one of the reasons also why we're very popular among very large infrastructures. You don't see us as much as in little startups, but you go in and you look at the big banks and you look at big insurance companies, guys who have to manage not just hundreds of systems, but hundreds of thousands of systems. You see a lot of salt because nothing can really scale like we can. I mean, it's kind of ridiculous how well we scale, especially compared to the other players.
Got it. Awesome. And you mentioned that it started like 13 years ago, and you've been in the space in a very interesting place to see how big enterprises manage their configuration and their infrastructure. From your perspective, what what happened or what is happening for the past 13 years, maybe 10 years compared to what's happening now, more or less?
So one of the things that's really interesting is that we've seen a really fascinating kind of curve happen. We go back in time to say 2008, 2009 and the late aughts, and what you're looking at is the emergence of an open source saturated infrastructure market. And back then we were still following kind of a classic lamp stack approach, a lot of on-prem infrastructure. There wasn't a whole lot of automation that was out there. So, for instance, Yahoo's infrastructure was managed by an 80,000 line Perl script. And and so these ideas that were emerging around idempotent infrastructure and DevOps were very, very new. And what happened is we saw the emergence of infrastructure as code. And really, I mean, CF Engine was the origin, but tools like Puppet Chef and Salt, we really created uh, the modern viewpoint of infrastructure as code back in that the early teens. And the big shift that this did was it began the movement to shift left development because we started to say, well, we can automate more and more and more and more and more of this pipeline so that we're not just building an application, throwing it over the wall, and then just allowing your system administrator teams to manually deploy it. And this started to enable a new type of scale inside of data centers that we saw really explode in the early teens. And at the same time, we began to see the emergence of cloud computing and uh, tools like AWS and Azure and the cloud wars, of course, of the early to mid 20 teens. And so along those lines, we saw tools like Terraform come in and create dominance around automating the cloud. Of course, Kubernetes shows up in 2014. And we began to completely rethink how applications are deployed and managed as a whole. And we saw this overall shift in the market. Now we go back and we talked to kind of a Kubernetes viewpoint, and they're kind of like, well, kube everything. And I always kind of rolled
Mhm.
my eyes at these guys, and kube isn't everything. It was fascinating, especially in the last few years at VMware, to see the level of saturation in the market of mutable virtual machine infrastructures, and how many organizations just have no interest in getting rid of this, and don't feel that Kubernetes is better. And then we have another phenomenon because again, all this automation has created a situation of, I would argue, significant complexity inside of infrastructure as code. And we've presented a completely different level of logical complexity to a developer. And that we need to think about tackling what the developer's logical level of complexity is that they're dealing with today. So yeah, I mean that's what I kind of say the journey has been over the last, say, 15 years into what now is a world where there's orders of magnitude more compute than there was 15 years ago, just in general.
Definitely. Yep.
Um, yeah, but also, so much more complexity, while at the same time, the actual needs around applications, I don't think they've changed a ton if you kinda really dig down into what data center applications need. So, yeah, I mean, that's kinda my view on where everything has been and is.
Got it. And you just mentioned the increased complexity in the infrastructure area. Can you zoom in on that? What do you think became more complex?
Well, what became more complex is that traditionally you would look at an infrastructure and you would say, okay, I've got to manage my hardware. I need to provision servers, and then I'm going to have a few databases, some storage, a load balancer, web gateways, and web servers. I mean, this is a classic distributed lamp stack. And with the emergence of cloud computing, all of a sudden we don't have to manage infrastructure directly, which is great. But what happened is that one thing that kind of surprised me with the emergence of cloud computing, my thought at first was, well, okay, there's this very obvious curve where it becomes less cost effective to maintain infrastructure in the cloud. And so I assumed that point on that curve would continue to move to the right, where it would be more and more cost effective over time to be in the cloud. And I also assumed that companies, when they pass that point in the curve, that they would look back at moving on prem. But I was a little naive at the time. I didn't realize that AWS would create so much product stickiness by having so many different applications and services that are available. And so all of a sudden, these infrastructures became tied in to all of these applications inside of AWS. I mean, sure, you can set these up yourself locally. And if you know what you're doing, honestly, it's not too terribly difficult. But again, that stickiness meant that they were able to take that initial setup cost and impose the convenience and the lack of expertise needed to overcome that initial setup to bring somebody into an extremely sticky product. And instead of uh, the value proposition shifting from left to right on, how much infrastructure you have till it makes more financial sense to move out of the cloud, it's shifted to the left, which really surprised me because from a raw finance perspective, the cloud is disgustingly expensive, and it's become much more expensive. We don't see the same level of compute optimization that we used to, which goes back into one of the interesting things we're seeing today, which is it's not as publicly broadcast, but we're seeing a very large motivation, especially in these very large enterprises, to migrate out of the cloud because they're able to see um, that it costs so much more money to be in the cloud than out of the cloud, that it's worth it for them to bring on that business risk. And so that's been a very fascinating transformation to watch over time. But again, it's created different types and levels of complexity because you go from needing to manage with tools like Terraform and OpenTofu, of course, to um, to manage all these different apps.
Yep.
And these companies that are running the cloud exit come back and they say, we're not losing a whole lot of time just building this ourselves.
Yep.
Um, as long as we've achieved a certain scale, then the business risk, which we have to calculate into that as well, can be overcome in a reasonable fashion. And so again, it's yeah, the overall complexity of infrastructures has become kind of terrifying.
Yeah. So basically, you're saying it's not just having an EC2 server that is replacing your on-prem or VMware kind of virtual machine. It's a whole bunch of dedicated services within these cloud providers that make the experience there super sticky. So the value proposition may be change from just being optimized for cost and scale just to being, let's say, cloud native and operating your entire applications in cloud in a very complex way. And I think also you didn't mention microservices, the shift from monolith to microservices that kind of change how applications are being built today. And it's no longer just one big piece. You said earlier Perl, but let's say the more common Java applications or something like that. And now it's spreaded all over so many small microservices that each run on different type of cloud resource. So how do you bring that thing to on-prem? That's a big challenges, as you mentioned, some operational risk you calculated in this query of what should I do as an organization. So yeah, definitely different type of operational challenge for these companies today.
Oh, definitely. And I mean, I'll be pretty clear. I'm not a fan of microservices. Now, there's a lot of there is a lot of benefit that you get from a Kubernetes perspective. But it's at the expense of changing where your complexity management is and where your risk management is inside of your business. And I've gone over too many uh, company surveys and evaluations over the years where they show that their shift to microservices cost them far more money than it saved them. That the overall implications were frankly pretty negative. And I mean, I almost feel like I have to be careful about saying this because the vitriol around Kubernetes and microservices has been so heated. But I sit down with these executives and just ask them in a very benign way, like, if you're honest, you've been on Kube for 4 or 5 years. Are you saving money? Is this more efficient to you from a complete organization perspective? And they almost universally come back and say it's eased up a few areas of system management and deployment, but that overall our costs have gone up dramatically, and that it's added types of complexity around their application development stack that they didn't foresee. And I think that the breaking up into microservices has been, I mean, so my net on it is that I'm not a huge fan. The other thing that fascinates me is the emergence of these businesses that are managing internal APIs. And the fact that you create such incredibly complicated internal APIs that those also can be inherently become a big problem. Integrating with, I mean, APIs are fantastic to have, but the amount of work that we put into integrating with APIs these days is kind of disgusting. We don't spend anywhere near as much time as businesses working on actual business applications. I was talking to one of my buddies at NASA the other day, and he was bemoaning that he said, "Look, we spend literally all of our time writing Helm charts and Terraform code, and we don't put stuff in space anymore." And that's almost universally the problem that I'm running into is people coming back and saying, we love the fact that we have this level of automation now, but just automating things has become the full-time job. It's completely taken over. It's like we had a rat problem, so we released snakes, and so now we have a snake problem.
Got it. Interesting. So it sounds like you're getting some interesting thoughts from executives and colleagues about what's going on, and maybe the Kubernetes and microservices is not ROI efficient. Do you think those signs that you're seeing, or basically what do you predict that's going to happen in the next 5 to 10 years when it comes to this level of automation and maybe the shift from monolith to microservices and the entire approach that we've been seeing in the last 5 and 10 years? What would you expect to happen in the next 5 to 10 years?
So the first thing that I'll go over is that this pendulum of monolithic to microservices, this mindset is not new to the industry. This is a pendulum that has swung back and forth for decades. So, I mean, if we go back in time, to the late '90s and the early 2000s, we had a big push around static binaries and static monolithic deployments. I was fascinated. A large financial firm, I can't legally say which one, but but a very large financial firm that I'd worked with, their entire application stack was a single monolithic binary that was something like 20 gigabytes. I mean, it was ridiculous, but it worked. And talking to him and saying, "Well, why'd you do it this way instead of more of a more of a shared library approach, which is similar to, philosophically something that's more microservice oriented, from an iteration into the past. And they kind of said, well, that's just what people were doing at the time. And so we kind of got stuck with it. And they said, but it works. And I was like, hey, if it works, it works. I'm not here to tell you not to do something that works. And so when we come back and we look at uh, this philosophical pendulum that swings back and forth over generations, this is a very common thing that happens across a lot of different social structures in humans anyway. Um, and so I suspect that these companies are going to be grappling with trying to figure out how to cut costs, how to be able to deploy the compute resources that they need at lower cost. And that they'll look at the microservice architectures. And we're seeing this a lot now, is looking at these microservice architectures and saying, no, 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 no. This is too expensive. It's too expensive to be on the cloud. It's too expensive to deploy inside of Kube. It's too expensive to have my developers create all these different microservices that are deployed this way. And my hope is that they come back and they say, okay, look, a lot of the microservice idea is really good around code isolation from a development perspective, but that we need to rethink our deployment to be in a way that can be more reasonably managed. And this goes back into kind of what I'm working on now, is figuring out ways to lower the infrastructure as code burden, while maintaining high at scale automation and deployment of software. Because again, we've like I said before, we had a rat problem, we released snakes, now we've got a snake problem. How are we going to take care of the snakes without
Why
making
why didn't
without
you use
making a honey badger
cats?
problem?
Cats are also quite effective for rats.
Yeah, I
Maybe
mean,
cats were better.
yeah, no, that's true. I mean, you can have a cat problem. It's not quite as bad as a snake problem.
Cool. So yeah, super interesting to hear your thoughts. Sorry for interrupting you with the cat's analogy. And Tom, thank you so much for sharing the story of SaltStack and the how infrastructure and configuration management has evolved throughout the years. So I want to thank you today for joining us, Tom. Thank you so much.
Yeah, thanks.